This section is 11.2, deals with one-sided limits. And limits involving infinity. So this is really two lessons wrapped up in one. A one-sided limit is what happens as we approach x from one side or the other, not both. So recall from last time, we said the limit as x approaches something equals the number if x approaches c from both the left and the right. But sometimes that's not what's happening. So now we have this situation. This is still a function. It passes the vertical line test, but at this value, let's put a number on this. Let's call this 3, just to put a number on it. Let's call this 1 and this 4. So what's happening as x approaches 3? We can't say it has a limit. The limit as x approaches 3 does not exist. Put it this way. Can I tell you it's approaching 1 as x approaches 3? Well, no, because sometimes it's approaching 4, sometimes it's approaching 1. It depends on which side you're looking at. But now we're going to define one-sided limits. I'm going to keep this graph up here so we can refer to it. Make sure that makes it onto my screen there. All right. So we can say the limit as x approaches 3 from the left of the function. So this little notation here means from the left. Careful what that says. It doesn't say going leftward, it says from the left. So from the left means if you look at the graph, what height are we approaching as we're coming from the left? We're approaching a height of 4. So as we're approaching 3 from the left, that's 2.9, 2.99, 2.999, and so on. We're approaching a height of 4. Do we ever get there? No. But remember, limits don't care that we never get there. They just want to know what we're approaching. We can also use this limit. This is the limit from the right. So it's a tiny little plus sign there, but it means coming to the value from the right. I'm going to put little 3's right here. So what height are we approaching the function as we come from the right? We're approaching a height of 1. Does it get there? Yes, but I don't care about that. Limits don't care about what we're actually getting to. All they care about is that we're getting towards something. A couple more notations that we need to worry about. Some special cases are going to pop up. Sometimes in algebra we have vertical asymptotes. It's called a vertical asymptote. Weird Greek word. It just means vertical line. It just means a line that your function has to approach but never does quite get to. So here, the vertical asymptote is when x equals 2. So what happens as x is approaching 2 from the left and from the right? Well, we can say the limit as x approaches 2 from the left and the limit as x approaches 2 from the right, we're going to call these something. We're going to say that the limit as x approaches 2 from the left, so that's 1.9, 1.99, 1.999, do you agree that this is going up forever and ever and ever and ever? It's never going to quite touch that vertical line. So if it's up forever and ever and ever, we're going to use the symbol infinity. That's just so we don't have to write up forever and ever and ever, because that would be silly. We're not going to do that. The limit as x approaches 2 from the right, that'd be 2.1, 2.01, 2.001, and so on. We're going to call that negative infinity. That means down forever and ever and ever. So don't get too perplexed by the symbol that called infinity. If you're talking about the y direction, infinity means up forever. Negative infinity means down forever. As we'll see in a minute, if we're talking about x values, infinity means to the right forever. Negative infinity means to the left forever. So let's find some of these limits. Limit as x approaches infinity, 10x squared minus 5x plus 8 over 3x squared plus 8x minus 29. Now hold on. This says as x approaches infinity, but we just said if x is going to infinity, we're talking about all the way to the right. So what this question is really asking is this approaching a height all the way to the right? What happens to the function as it goes that way? So I don't want to graph this. I can, don't really want to. But what I'm looking for is what's the largest power of x? The largest power of x is 2. So what this means is divide the top and bottom by x squared, like this. As long as we divide everything by x squared without any mistakes like that, do you agree we can do that in algebra? We can divide by the same thing as long as we do it to everything. Now what happens as x gets really, 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 really big? Well, we can reduce. Notice 10x squared over x squared, the x squareds cancel. Same thing with the 3x squared over x squared. 5x over x squared and 8x over x squared reduce, and we get this. Now here's a really neat property about infinity. X is going to get big. Now, I mean really big. Really, really big. So big, we can't even find a number. So as x gets really big, here's what I want you to note. The limit as x approaches infinity of anything over x equals 0. X is infinity. It's infinitely big. So I don't care if you have 50, 500 on the top. You're going to have billions on the bottom, right? And it's just going to keep on going. Well, that's going to get closer and closer and closer to 0. So look back at our problem. The limit as x approaches infinity means we can just take the limit of each and every single one of these. So what's going to happen to this? What's going to happen to that? This is going to go to 0. This is going to go to 0. This is going to 0. And this is going to 0. I know they're different. I know they have different details. But do you agree that as x gets infinitely large, x is huge, x squared is really humongous. And now you just end up with 10 over 3.